Thanks for joining, everybody. Welcome to KETIV Virtual Academy. My name is Christina Ung. I'm on the marketing team here, and I help facilitate these sessions. We're so happy that you're here, and we're so happy to have Tiffany Hayden back. This is part 2 on her planning for automation session. And thanks for joining, everybody. If this is your first session, welcome. We're so excited that you're here. You will get an email 1 hour before each session on Thursday with the topic, as well as a monthly newsletter. So that went out yesterday. And that newsletter let you know all of the topics that are happening in the month of September. We also have our KETIV website where you can check out all of our upcoming sessions or check out past sessions. And yeah, on the next slide here, I do have a list of all of our upcoming sessions. So next week we have Javier Chavez joining us, and this is going to be on transitioning from 2D to 3D. We got some feedback that people wanted to see this done step by step, so that's what we're going to be doing. We listen to your feedback. And then we have a session with Snigdha Sarkar on ANSYS simulation the following week. And the week after is going to be with Jose Paredes Clara. So be sure to join, check them out. And at the end of the session today, you'll receive a link to give us some feedback. Let us know what you thought of the session. Give us any feedback, anything that you'd like to see more of, less of. We are all ears. So be sure to fill that out. It helps us make the program better and make changes like how we're making changes next week. So thanks for joining, everybody. I'll let Tiffany take it away.
Hey, everybody. Today we're going to focus on automating for assemblies and preparing for automation. The first thing that we are going to do, and if you joined the last time with the part automation, we're going to use WorkPlanes and then drive those WorkPlanes with parameters and iProperties and create a simple iLogic form and have a rule that is driven off that iLogic form. If you don't know me, or if you didn't join the last session, I am Tiffany Hayden. I am an application developer for KETIV. I am newly to the Expert Elite program with Autodesk, and I have been in various forms of design automation for about 15 years, primarily in the material handling industry. If you're not familiar with material handling, that's pretty much conveyors from where it gets dropped off to the distribution center, and then when it leaves to go to your house. So we have a lot to cover today, so we're going to jump into the, let me stop sharing and share this other screen. Sure. Okay. So if you joined the last time, this was the finished product of the part automation side. We are going to make one slight adjustment to this part, and it's primarily going to be having the ability to configure and actually save out the part. So what we'll do is we'll create another rule, and we will just name it create new file. And then inside of this, we will have a very simple iLogic code. And I'll kind of go through this. So we have the part document is the first thing that we have to create an object for. The next thing is we're going to be pulling the model name from the part, and that is going to be our file name. So I created a path to this folder, and it's just going into the GitHub repository local path. And then when it saves it out, it's going to go to that path and then save a file named that model name .ipt. That's simple of what it is going to be doing. I'm going to minimize this a little bit because it's enormous. Okay, we're going to save it and close it. And then we need to also change the form and add that rule to the form so we can run the rule. Yeah, that's fine. And click OK. And so now we have two buttons. We have one that drives the rule and one that creates the new file. You can make the name of it anything you want. I just said create new file, but if you want to save as anything. The files that we're going to save out, and they're kind of familiar to our last session. We're going to create 3 files, one of them being ATQ-36-120-N. This is going to be a 36-inch wide, 120-inch long without handles. So we're going to drive that model, which will drive the component, and then we're going to create a new file. And you can see that if I show you here that the asset got created within the assets folder within that path that I said earlier, or I showed you earlier. And we need 2 more files. So I'm going to create drive model, create new file, and drive model, create new file. And you can see all 3 of them have now been created. So that's really all we need to do to the part. We have our files. We're primarily going to be dealing with the assembly now. So when we dive into assembly automation, the first thing that I typically do is I create the work planes that I'm going to need. A lot of times that's standard work planes that you have with other assemblies and parts that you just create new, or you have some sort of template that you build off of that already has a lot of the standard work planes and work points that you're going to use for your automation. In this case, we don't have that. So we're going to create all of the work planes from scratch. So let's, from our last session, you'll know that we always use the origin planes to create the work planes. This is primarily based off of just security and stability. Creating the work planes based off the origin, the origin planes are always going to be there. That's kind of it. Just create a stable assembly when you do that. So we're going to create a work plane, and the first one, let me zoom in so you can see the position. So the first one's going to be on the XZ plane, and I'll just kind of drag it away so that it just needs to be at 0. This one is going to be named plane in. And then we're going to have another one at XE. I'm going to just drag it out a little bit. And we'll name it plane out. The next one is going to be the horizontal work plane. So just drag it a little bit, but it needs to be at 0. And it's going to be plane top. And then the center line, which is the YZ plane, we're going to create a work plane off of that. It'll be at 0 as well. And we will name it plane center CTR. And then a work plane off of XY, we'll drag that down as well. And that is going to be the plane floor. So a lot of ways, if you're dealing with equipment that's going maybe in a building, let's say, you want to mark where that floor is, because the floor can change. Sometimes you're, going on a floor, sometimes you're going on a mezzanine, sometimes, the levels change. So you want to have where that floor is located. So if it does change, your equipment moves with it in your higher level assemblies. So it's good to have a work plane for that. And then the last one is going to also be the XE plane. We're going to drag it a little bit further that way and rename it plane gate in. So those are going to be our primary work planes. We're going to create a few more later, but these are going to be the ones that are primarily driving a lot of the equipment that we're going to put into this assembly. The next phase is parameters. So let's go into the parameters box, and we're going to add a few user parameters. So first one is OAL, which is shorthand for overall length. And we're just going to put that at 1,000 inches for now. Gate location. And we're going to put that at 300 inches. Whoops. Make sure and do lowercase, lowercase inches, because it doesn't like uppercase inches. And then height. And we're going to put that at 120 inches. And for now, that is all the parameters we're going to put in. So there are a few work planes that need to be pointed to those parameters. So plane in is going to stay where it's at. It's always going to be at 0, 0. Plane out is going to listen to OAL. So you want to make sure it's going in the right direction. So we have to kind of zoom out. There you go. It's going in that direction. It's always good practice to make sure your work planes are going in the right direction. I don't know how many times that I have accidentally put it and didn't put a negative when I needed to, and it just reversed the direction. And then why are my components in weird places? It's really good practice to just zoom out and see where it is before you accept it. The next one is going to be plane floor, and we're going to put it at height. But in this case, it needs to be negative height because it's going up and we need it to go down. So, and then finally, the gate, plane gate in needs to listen to the gate location. And then you just zoom out and it's over there, which is the right direction. We're good to go. Now that I've zoomed out and all of the work planes are very, very tiny, you can hardly see them, but they do exist. If I highlight them all, they're there. So now we need to place those parts that we just created. I have, let's see, place. So we have 3 parts. We're going to add this ATQ-36-120-in. We're going to add it twice. So we're going to just click twice to see in 2 different locations. And there you go. The next one that I need to place is the gate itself. So I'm going to add one of those. And then the final one is the 60-inch dash in. So, okay. So now we have 4 components in the assembly. And the next thing we'll do is do some constraining. So since these components were all built off the same asset, the same base component, you can depend on certain work planes to be there. So you see how, like on the assembly level, we have all of these work planes. Some of them are very similar to the work planes that we have in the part, especially plane in, plane out, plane center, plane top. Those are all very similar work planes in their locations of the part versus the assembly. So for this first component, we're going to go through and constrain plane in to plane in of the assembly. And you see how it's going in the opposite direction? It's facing this way. I don't want it to do that. So I need it to be a flush. And then you hit apply. And then let's do center to center, which it's going in the right direction. So that's good. And then we'll do top to top. All right. And then this second component, which is this, the third one I placed, the plane in needs to be at the plane gate in. So it's going to, and it's going in the right direction, which is direction of flow. We'll just hit apply. And then center to center. And top to top. Hit apply. And then the last component, we won't do the third component right now. We'll do that here in a second. But the very last component is going to, it's going to be this last 60-inch long one. And we're going to do the plane out to the plane out of the assembly. And then center to center and top to top. Well, what did I do? Oh, okay. Let me make sure that I have those constraints right. Yeah. Center, center, top to top, and then the out. Okay. I just had one of the components on top of my other one, so it just kind of looked a little weird. But it's not constrained yet, so that's why it looked weird. So there are a couple of work planes that we want to bring up from the part level and create assembly work planes for those components. The first one that we want to do is the plane out of the gate itself. So let's do a work plane from the plane out. And I gotta kind of scroll in and change it to 0. So that's going to be a work plane we're going to use for some of our features. The next work plane is going to be the last component, which is this component. And we're going to name it, or there we go, 0. Okay. So now we have 2 extra work planes, and the awesome part of, I think it was in 2024, but it may have been new in 2025, is you can now rearrange work planes in assemblies. You didn't used to be able to do that. And it makes it just makes your assemblies very clean when you can put all your work planes together and all your components together. So we need to rename these. So this is going to be gate, plane gate out. And this is going to be plane out offset. And then you can just drag them up. And there you go. All your planes are in the same place. So this component, we still have left to constrain. So when we are constraining it, we need to constrain the plane in to this new work plane we just created. And we need to flip it because it's not going in the right direction. So it needs to be a flush. And then we do center to center and top to top. Okay. We have all of our components in place. It does not look like it's filled in, but don't fret. We're going to fill it in very, very quickly. The next thing that I like to do is rename the components in the tree to be a little bit more, I say generic, but a little bit more specific to what the component is and not a file name or a part number. That makes it a little bit easier to identify which component is which. And also in your code, you're not having to write out this long file and then a colon, 1 or a colon 2 on the end because you had multiple components. So we're going to go through the model tree and rename them. So we have comp in. Oh, try that again. Comp gate, and comp out. Okay. And then we're going to create 2 patterns to drive this component and this component because we need them in a pattern to fill in this gap that we have between the components. So we'll do a pattern and then select the component. And then we will go in the Y direction. Make sure that that's the correct direction. Y. Yeah. Okay. And for this specific one, we'll just go 3 for now and at 120 inches. And you see that this is kind of running into the gate right now. That's going to be taken care of here in a minute. But we're just trying to create our create the pattern. We can drive them with the parameters in the future. And then we're going to create another pattern to fill in this gap. So listen, that's looking very strange. Okay, there we go. Okay, then we need to do the Y direction. And for this instance, we'll do 5 at 120 inches. And like this one, it's running into the last component. So we'll get that cleaned up. All right. A lot of times when you're dealing with manufacturing, in many businesses I've dealt with, is you're a lot of times you're still ordering a full length component, but you may need to show it in a different way. And to do that on an assembly level, to keep the bill of material the same, you want the component to not be edited at the part level, but you can actually cut away material from the assembly level. And we tend to do that with assembly cut extrusions. So you can, but to do that, we need to create a sketch. So we're going to create a sketch on plane gate in. And then I typically use the 2-point, I think it's a 2-point, and then just make it fairly big. So 100 by 100 should be big enough for what we need. And then you can quickly constrain it from the center point to the origin center point. And it just kind of makes it a little bit more easier instead of more constraining. You're just constraining one point to point. All right, so we have that first sketch. I'm going to turn visibility off on that first sketch, just because when you create a second sketch, it'll be right on top of each other. And sometimes it's hard to get those points correctly constrained when you're dealing with multiple sketches on top of each other. So the next sketch we need to create is going to be on this plane out offset. And kind of like what I did, in the previous episode, I kind of draw my uh, squares or circles or anything away from my components. In this case, it's just not touching any of my components is what I mean. But a lot of times you want to draw it away because in some instances, if you have like certain settings, the auto projecting of geometry happens, and you may or may not inadvertently turn things on that you don't, or auto project things that you didn't mean to auto project. So it's good practice to kind of draw your stuff away, or at least to where it's not hitting your other material, if you can, if it's possible for what you need. And I didn't auto do the dimensions, so we're going to go ahead and add 100 by 100. And it's more of like how big of a material that you're dealing with. In my case, it's only 36 inches wide, so 100 by 100 is going to encapsulate anything that I need. But if you have a very large assembly with very large components, you may have to increase that from 100 to 500, 1,000, whatever suits you. Okay, so now we have two sketches in the assembly. And now the next thing that we need to do is we need to create an assembly extrusion. So we'll do two different ones. So one, it needs to go in the flow direction, and then we'll just make it 120 for now. And then a second one, and it needs to go in the reverse direction, and then 120. So you see how these kind of show up at the top of the, like, before all of the components or work planes. That's not a mistake. That's just where they're located. It's kind of above all the features are first, and then you have all your components later. But when you do an extrusion and you have material to cut away, it automatically adds certain components to as participants to those cuts. So there's you want to make sure that you're actually cutting away the things that you would like to, because it's going to say, okay, well, I'm cutting 120 inches. Here's all the components that are in that path. Let me go ahead and add them as participants to this extrusion cut. But if you're not intending them to be cut away, and in this case, I'm not intending some of them to be cut away, so I'm going to go ahead and turn them off or remove them as participants on some of these. So this first extrusion, I don't want it to cut away the gate, so I want it to stay the same. I also don't want it to cut away the comp gate, so I want to remove it as a participant. And then on the second one, I don't want it to cut away the comp out, so I need to remove it as a participant. So you see how they kind of popped back in place, and this is ending at the gate, and this pattern is ending at the last component. So something that I put in on the idea boards for Autodesk Inventor, and I'm hopeful that it changes in the future. But to be safe on extrusion cuts, you want to automatically add if you're dealing with a pattern, you want to automatically add the first component of the pattern. A lot of ways those aren't going to be cut away anyways, but it's a safeguard, because if you are dealing with code and you're removing all your components that are part of the end of the pattern, the elements that you want to cut away, if you ever run into a situation where you're removing all of the participants from the extrusion cut, the cut actually disappears, which is it's not a bad thing, but if you're dealing with on a programming level, it can be very hard to have to recreate that cut every time. Yes, you can create code that will do that, but for my practices, I've always wanted to keep the same extrusion cut available, and then I just add a default participant, which is usually the first participant in all the elements of the pattern. And then I never have that problem where my extrusion goes away. It's always there. It's always part of the extrusion cut. So what we're going to do is we're going to do that. I need to right click on here and add participants. And then we're going to go down to the pattern and add the first element. And then for the second one, I want to right click and add participant. And then I go down to the second pattern and add the first component. It doesn't cut it away because it's not in the path of the extrusion cut. It's just kind of a safeguard that these are going to be the default values that are in this extrusion cut. And when you do remove participants or add participants, you want to make sure and ignore that default value. So in your code, you would just have, as long as it's not this value, you can remove it and add it. It doesn't really matter. And I'll go through that code here in a little bit. So we've added more features, so more cleanup is needed. So let me get out of that. The first pattern we're going to rename to PAT in, which is just pattern in the in location. And then PAT out. And then we're going to do EXT gate and EXT out. You can also rename the sketches if you have a naming scheme that you are familiar with. I'm just going with a three-letter acronym for my starting identifiers for my features. And so if you want to keep with that theme, you can do SKC gate and SKC out. Just everything's kind of clean, ready to start the coding practice. So we add in the patterns. Now we need to add parameters to control those patterns. So go into the parameters and let's add a few more user parameters. So we'll just do PAT in QTY, PAT in offset, PAT out, QTY, PAT, oh, I have to fix that. PAT out, offset. I don't know what I was typing. Okay, so for quantities, we have to actually change the unit type to unit list. That's just what needs to happen. So we would change the quantity to be unit list, and then this quantity as well to be unit list. And then you have to just put in any number and hit enter, and it'll update the units for the equation. If you don't do that, it's going to stay red. So just do 1 and then enter. The default values for these right now is going to be the default values that we already put in there. So 3 and then 5 and then 120 and 120. Okay. Hit done. And now we need to connect those parameters to, or connect the parameters to the values in the patterns. So for this one, just double click on the pattern. We'll have PAT in quantity, PAT in offset, double click on the out pattern, and we'll do PAT out quantity and PAT out offset. All right, nothing changed because the values didn't change, but now everything is connected to the parameters, and now you can drive them through iLogic or VBA or whatever that you're driving from. Okay, so the next thing that I'll do is add iProperties. So we will have a few different ones. We'll have family. And for this one, it's just going to be one family because that is what we're doing for this assembly. You can expand this and make it control many different families, but for right now, it's just going to have one family. So this will just be the default value. We won't change it for this assembly, but it is possible to expand this further and make it to where it'll update the family as well. And then OAL, and we'll just put in 1,000. Gate location, and we're going to put that at 300. Height, 120. And then hit apply and close. Okay, so for this assembly, we're going to control it using an external rule. If you're not familiar with external rules, it's just a rule that you can store it outside of Inventor, and it can be called externally to Inventor. So if you have Inventor as the graphics engine, it could be called through VBA, it could be called through VB.NET, C#, whatever other programming languages that you have, or it can be called by the user itself and by just right-clicking and running it. So when we need to add an external rule. Well, hold on. We need to create an external rule. Create an external rule, and we'll just call it assembly. External rule. Very simple. And .txt. We'll just call it txt for now. Okay. So for this one, we'll just hit save and run for now. We'll add some code in there shortly, but we need to go to the and create a form. So add form, and we'll just do drive model. And then we need to go to the iProperties and add all of these properties that we had. And then we'll also add a button to run the external rule from the form. And you can make it as big or as small as you need. So we'll just hit OK. So now when you hit drive model, it has all of the iProperties and a button to run the external rule. So now we get into the external rule code, and I'm just going to copy all the code that I've written to control this assembly in here. And I will quickly go through some of the components of this external rule. This external rule is also documented in the Autodesk community blog that will be in the chat and in the description of this video. So if you would like to have a more really in-depth look at what the code is doing and explanation of exactly what the code, step-by-step of what the code is doing, it would be good just to look at that too, to get a little bit more understanding. But I'm also going to go through this, but at a little bit higher level when we're looking at the code. But to get a more in-depth look at that blog, I go through it very in depth. So when you're dealing with external rules, you have to kind of start at the document level a lot of times. So most of the time you're dealing with an active document. The active document in this case is going to be the assembly that we have open. The next thing that you do is you create the component definition off of that document. And to get to the component definition, it's just the document dot component definition. So the object is going to be an assembly component definition off of that assembly document. The next thing we need to do is grab the iProperties off of the document itself, the values for the iProperty. I created a function inside of this rule that will easily go and get the iProperty and bring it back to you to use inside of this, inside the external rule. The good thing about that function is that it looks at all the locations that you could have properties or iProperties. And if it doesn't find anything, it's going to return an empty string. Or the value is empty string, it'll return an empty string. It's not going to error if an iProperty doesn't exist. And in some instances, when you're dealing with some of the snippets, if you try to give it an iProperty that doesn't exist, it'll return an error, and you don't want that to happen. So this function just kind of loops through all the iProperties. If it finds it, it'll return it. If it doesn't, it just returns an empty string. So it kind of saves you from having to error handle certain iProperties. It's just going to return an empty string, and then you kind of have to dive into why that iProperty doesn't exist. So in this code, the next thing that we're going to do is we're going to get those iProperties and push them into the parameter expressions. And that's just going parameter.param, and then whatever the parameter name is, and then dot expression. So a lot of times you're coming from iProperty, going into a parameter, you're going to go from a string to a string, and to push a string into the a parameter, you need to push it into the expression. So that's kind of what that does. The next level is actually formatting the iProperties in a standardized way. We do this with a function that's called convert decimal to feet inches. You can use this, you can use different formats if you want. I'm just converting anything that I find into a feet inch format. And that's just a lot of times for consistency. You want to make sure that certain values are a certain format. So when you go to like drawings, that your description for that drawing is correct and it's coming through the way that you're expecting it to. Because the user can put anything they want in there. If you don't have some sort of coding base that is double checking the formatting, having like a function to do that for you is an easy fix for that. The next thing we'll do is do an assembly update to just update the iProperties visually. We're going to do some measuring to determine between two planes what the distance is. And that is going to give us the amount of space between two planes that we need to fill with the pattern. So we're going to use that information and calculate how many of those, at least how many components will fit. And if it runs over a little bit, that's fine. We'll just use the extrusion cut to cut away any material that's needed to be cut away. But to get an accurate representation of what those two between those two planes are, it's good to use some sort of minimum distance measuring, and you can do that inside of iLogic. Another reason why you would do a document update is to make sure that everything in the assembly is up to date before you start doing measuring. A lot of times things can move around, and you want to make sure that I'm taking a measurement from the latest and greatest. So for sometimes for the components, we want to grab information from those components. And that's another reason why it's good to like shortcut the name as much as possible to make it specific to what the component is, but easy to write in code and easy to not fat finger. So in this case, we want to create a parameter or a variable, and that's just called gate. And that's going to be the component name of the thing that we're trying to grab. So it's going to go and grab the component from the model tree and bring it in as a component occurrence. And then we want to grab the document off of that component occurrence, which you just do .definition.document. And then we want to grab the parameter off of that document that matches whatever parameter we need. In this case, it's going to be length. We need to grab the parameter from the gate called length and use it. So this is an easy way to kind of dive down into components that are in your assembly and say, so you're not having to like create parameters on the assembly level and like redefine them. You can just grab parameters from your components and kind of bubble them up to the top and reuse them. So we're doing that for the gate and the comp out because those two are a little bit smaller. They're 60 inches both, but they could be something different. So it's good to, you know, go and get that parameter, whatever that parameter is, value is, go and just retrieve it. And then we're defining that the minimum distance is the pattern length, the first pattern length, plus the gate length, plus the component out length. So a lot of times in your code, you're having to error handle. So in this case, we wouldn't want the user to input an overall length that's shorter than what we can do. So when you are putting in the code, you're saying, well, here's the minimum length that it can be. If it's anything other than that, we want to set it to something a little bit bigger and then drive the model. And of course, alert the user, but we don't want the model to error because we put in a bad value. We want to catch that if we can. So that's what this is doing. It's just saying if the OAL is below the minimum OAL, alert the user with a message box, change the expression of the OAL of the assembly to the minimum OAL, change the iProperty to the minimum OAL, do an inventor update, and then remeasure. So that's because we want to continue on if we can to finish out the code because we need to remeasure and then use those values further down. And that's really what's going on. We're redefining, let me see, these two values right here, we're doing a remeasurement and just redefining them, or not redefining them, resetting them to whatever, after they reset to minimum, what is the distance now? So we can continue with the code and accurately finish it out. So the next one is defining whether what that pattern in offset is. So we're grabbing the pattern in offset from the assembly level as the parameter. We're grabbing that value. We're defining what the quantity is based off of the pattern length in divided by that offset. And then we're defaulting the variable for visibility for the pattern to false. That's not setting it, it's just defining a variable. Then we're also defining the expression for the pattern to just be a pattern quantity of 1. That is going to be crucial in issues where you have a calculation problem and for some reason your calculation for the pattern is, let's say, less than 1. You don't want the pattern to error. So you want to reset it to 1 and then continue on. And then when you know that it's less than 0 or less than 1, you'll reset it to 1 and turn the visibility off on the pattern. you know that it needs to be something, but it doesn't need to be available. So you just change the quantity to 1 and turn the visibility off. So in this case, we're looking for the length to be greater than the pattern length to be greater than 0. And then we're pushing in the quantity into the expression for the pattern, and then we're changing the visibility to true for that specific instance. And then this is where we're actually doing, making the parameter changes. We're just redefining or resetting what the variable is going to be. And then at the very end, we actually touch the parameters and deal with we use those variables to deal with the pattern itself. So in this case, we're going to push that parameter expression into the PAT underscore in underscore QTY parameter expression. And then this is another subroutine that is inside of this code. But what it does is you give it the assembly document, you give it the pattern name, and then you tell it whether the pattern is visible or not. And if you say true, it's going to go through and turn visibility on the pattern and all the elements inside of it. Because in Inventor, if you turn the visibility on a pattern, it doesn't necessarily change the elements inside of it, especially if you're trying to turn visibility off. If you turn visibility off on the pattern itself, like the top level pattern, it doesn't affect all the elements inside of it. So what this subroutine does is it gets you the pattern, and then it loops through all the elements and either turns them off or turns them on, depending on what you tell it to do. And we're doing the same thing for the other pattern, the second pattern. It's just the only difference is that we're dealing with the PAT out instead of the PAT in. And then after we do all of those changes to the pattern, we want to do another assembly update. That is a crucial update. So if you're dealing with the assembly update after you affected patterns and you want to accurately add and remove participants from an extrusion inside of an assembly, you have to do an assembly update after you affect the patterns. Because if you don't do that, it doesn't know that the pattern has changed and that you need to look at the very last one. So let's say you change the length and it went from having 8 elements to 6 elements. Well, if you don't do an assembly update, it still thinks that there's 8 elements until you do an assembly update. So that's why when you're doing an extrusion and you're looking at patterns to determine what the last element is in the pattern, you want to make sure and do that assembly update right before you start messing with the extrusion, or you're going to add and remove things that aren't accurate. So for this one, this is another subroutine that is in this code. What it does is you give it the extrusion, you give it the pattern that you want to look at to add or remove participants, and then you also give it the default participant. So in this case, comp in is the default participant, which is the first one that's the one that's always going to be part of the extrusion, no matter what happens. We want to make sure that there's always at least one participant in the extrusion. So when you are what this subroutine does is it loops through all the patterns or it loops through the pattern that I tell it to loop through, and it looks at the very last element in the pattern and adds it as a participant, removes everything else except for the default participant. So that's what it does. It removes all the participants except for default and then adds the very last one. So it's always accurate. And it's doing that for both patterns. The very last part of this external rule is if you have assemblies that, let's say by accident, they turn visibility off on something, you may or may not want them to be added to the BOM. In my history, a lot of times we would turn visibility off on stuff and we would not want them to be added to the BOM because we had maybe, let's say, a template or something that we're using. And sometimes we use the components and sometimes we don't. So we just turn visibility off on it. So what this loop does is it loops through all the components and sees if they are not virtual, and also the visibility is on them. And if it is not on, it automatically changes the bill of material or the BOM structure to reference. So that and changes the ones that are on to default. That may not work for you for your situation. That can be edited. It's just thinking about using assemblies for bigger than what you are doing right now is when you are dealing with a lot of assemblies, template assemblies, where you have maybe half components in your assembly that you want to reuse, but we don't want to count them in the BOM. It's good practice to just loop through them and make sure that they're visible. If they're not visible, then we don't need them. And then the last thing we do is do a update when done. And we'll just do a save and run for now. Let's turn off some of these WorkPlanes so they don't. And let's go to the form and let's do just a little bit of playing around. So let's say we want to change this to 17 feet, and it auto changed that, cut away more material, made this a little bit bigger. Let's change it to 75 feet. You see how it cut away. Let's change the length to something really small, like 20 feet. Okay, so this is where that error handling happens. It's going to say, it's too short. OL is below the minimum length to accurately represent the design, automatically changing to the default minimum length. So go ahead and click OK, and it automatically changed it to where it was the minimum length that was available to do that. And that was pretty much affecting this second pattern. So what it did was it shortened it to the minimum to where the last component was available. And then it turned off all the elements in the pattern. And then it turned off the pattern itself, so it's not available. It's still here, but the element, like we said, when it's in that error state, when it's less than or equal to 0, or less than or equal to 1, it's going to change the element quantity to 1, and then turn off the pattern and all the elements visible, or turn the visibility off on those elements in the pattern. So that was kind of a long look at assembly automation. I'm excited to hear how you use it, and if it was beneficial to you. Let me change back to the presentation. So we did the demonstration. A little review, we did WorkPlane creation and parameters, went through consistent constraining practices, plane top to top, center to center, end to end. That having the same names on the WorkPlanes really helps with speeding up your constraining process. If you're not having to scroll through and oh, which WorkPlane is which. You'd be amazed on how quickly you can constrain things when you have consistent naming schemes inside your assemblies and parts. And then we went through iProperties, creating the iProperties and having them drive the model. And then we took a short look at the external rule and what was available in that. There's a few outside resources that we have in the chat as well, but the community, Autodesk community blog, this content is also on there in written form. It also has the videos, so you can look at the videos on a snippet basis instead of a full hour. And then the GitHub repository, it will have everything that we talked about today, Shortly after this this recording is over, I'm going to push all of the material that I created, the finished products, into the GitHub repository, so you can look at that as well. And now Q&A. Do we have any questions?
It looks like we already have a question from Philip in the Q&A. Do you see it right there? It says, I would expect the division to give you a decimal. How do you make it give you a whole number? Pertaining to the components QTYs?
Oh, no, unit list will give whole numbers. That's why we had to change it from inches to unit lists. Those are all integers. So that's why you don't want, you wouldn't want to push in a decimal into the quantity for a pattern or anything that you're dealing with quantity. You want to deal with integers, and that's how you do the unit. You can also do, I don't know if I touched on that in the external rule. You can also use ceiling or floor to make sure that it is a unit, or it's not only unit list, but it is also an integer. So it's kind of like rounding. You would round up, round down. Ceiling and floor does that. Ceiling rounds up to the nearest integer. Floor rounds down to the nearest integer. So I think I did that inside the external rule. I just didn't touch on it when I was going through the code. But I believe it is doing that. It's rounding up to the nearest integer using the ceiling function. Okay, can you create planes in the assembly from the parts using iLogic? For instance, when you place the part, the iLogic would then make the plane, or would you just access the planes in the parts directly? Create the planes in the assembly from the parts using iLogic. So I would create the planes in the assembly level, because unless you're dealing with one part, then yeah, you can bring that one part planes up to the assembly level and you don't have to recreate it. But a lot of times, if you're dealing with multiple components, you would want to make sure that your planes are consistent with what you want on the assembly level. So if you are, it kind of depends if you are dealing with multiple components or one component. But you saw how I brought up some work planes from certain parts up to the assembly level. So that's something that you can do. You can do that with iLogic. I'll have to dive into that. It's been a while since I created work planes within iLogic. A lot of the times I'm dealing with just standard work planes, so you want them in all the components, but it is possible to add them to the from the iLogic. Any other questions? Great questions.
Thank you so much, Tiffany, for hosting the session. And thank you to everybody that joined and is still on. We will have a replay of the session available tomorrow on our website. And you'll also get the replay when you receive our October newsletter. So that'll come at the beginning of October. Thanks for joining, everybody. And we'll see you guys next week.
Bye.